Okay, when we left off last time, we had written code that would calculate a Monte Carlo integration over functions that we could easily add. And we have 3 functions put in over multiple dimensions. We can do 10-dimensional integration right now. However, our code only works over the range 0 to 1. There was another problem that I noticed quickly. And it's a user interface bug, so if I hit integrate now without selecting a function to integrate, it integrates e to the minus x even though it says e to the x. That's because our default function here was e to the minus x, and our exact value was for e to the minus x. But in our title, we put e to the x first, so we should correct that. Make that e to the minus x, e to the x. Sometimes it can be hard to find all these user interface bugs, but you really want to have a good user interface. We can now rebuild the program and run it. Now it pops up e to the minus x. Do 16 iterations, 3,200 guesses, and integrate away. And we get the right value. All right, perfect. So how do we add this, make it extensible so we can now do limits of integration that exceed 0 to 1? Well, we have to go to our storyboard. And so we can come in here and add a label, limits of integration. That's good. Now we can add another label. Let's put 2 of them in here. We'll call this lower, call this upper, and then like we did before, we can put in a bunch of these text fields. So we could have that be for the first dimension. Then we got the second dimension, third dimension, fourth dimension. But this is quickly going to be unwieldy, and it won't handle anything. So this is not really the right way to do that. So let's just delete this. That's unhelpful. So what you want to do is put in here a scrollable text view. And in our scrollable text view, we'll be able to select different limits for each dimension. However, because we're putting everything in a single text view, we're going to have to write code that parses the text so it understands the limits of integration. So it's going to add some additional work for us. The other thing I want to do is put in a progress bar. Because right now, I don't know if the code is actually doing anything. I don't have any signal showing that any calculation is actually occurring. And that's not necessarily a good user interface. So we want to address that and fix that. All right, so how do we go about doing that? We drag this over, and then we'll have to connect both of these things. Now, the progress indicator has a nice feature, if I can find it. And we don't want to display it when it's not working. So we can just turn that off, and then it will not display unless it's actually doing a calculation. So perfect, we can do that. Now we have to wire these up. So we have to have our view controller up here. Okay. find it. There it is. All right. And for these scroll views, I find it easier to actually drag from here rather than trying to click on the actual text box because there are multiple views nested. It's easier for me to do that. And we'll call this limits of integration. Connect that up. And then our circular progress bar, and drag that in there too, and we'll call this progress indicator. Could have called it calculation progress indicator, but this will be good enough. Okay. Now that we have both of those wired up, we can close that. So if we now build the program, we can see the text box is there. I can type into the text box. Perfect. And my indicator, my progress bar is hidden, which is what we wanted. So now we actually have to go and make those do something. So we have to be able to read in the text, we have to trigger the progress bar, and so there are a few things we actually need to do here. And it doesn't necessarily matter what order we go about doing them, but let's start by creating a new file. And I'm going to call this text parser. So I could make this a class or an object. I'm not going to. I'm just going to go ahead and make this a function. So we're going to start with function parse string, and I'm going to take that parameter string, I'll call it string with the parameters, and we'll pass in a string to that, and we're going to have a separator, and this will be another string. And this separator is going to indicate what I'm actually going to use to separate the different parameters. You know, you often see this comma, space, tab delimited. For this one, we'll use a comma space. All right, and then we'll return basically a tuple containing two arrays of doubles. So we don't know how many dimensions that we'll necessarily have. So this function will parse a string of the form x.x plus the separator plus y.y with a control n. And the function needs to be passed a separator and in this case we will use comma space. Okay. So we know we're going to extract a lower bound. And that's going to be an array of doubles. And we'll start with nothing in there. Then we'll have an upper bound, which will be an array of doubles. And we'll again initialize that as being empty. Then we'll have a do loop. And so here we'll read the string of boundary parameters from the string that we pass in. Okay. So we'll put these in a contents array. And that will equal anything. It'll be a string. So we're going to split the one string into another array of strings. And there's a function, string with parameters, components, and then we can separate these. And we'll separate them by the \n term. So this will take our string that we pass in and break it up into individual lines, each separated by a return. All right, so that's the first step. Now, the next thing we want to do is remove any empty values. So if there were 2 return characters in a row, for example, something like that, we want to remove these because we don't want those. And so we'll say contents array equals contents array dot filter, and we'll filter these things based on checking that every value within contents array is not equal to null and empty. Why do we have that there? Oh, I'm missing an equal sign. There we go. Take care of that. All right, contents array equals contents array filter. All right, so now we have removed all the values. Now we want to step through this. So for I and 0 dot contents array array.count. And so for all the elements in contents array, that's weird. Don't know. That should be fine. Contents array dot count. Yeah, that should be good. Okay, well, we'll figure out what that is in a minute. All right, and then we'll say variable configuration string, and again, this will be an array of strings is equal to contents array of I dot components separated by and then we'll give it our separator. That's that one. That closes our do loop. I don't know why we're getting that error. Oh, in for I in. That's what it is. Yeah, not equals for I in 0. Yeah, all right. Got that one. Okay. Var component string is contents array I dot components separated by separator. Okay. And then again, after we separate out the individual components within each line, we want to then, again, remove any empty elements. And so we'll go again, configuration string. Equals configuration string dot filter, and we'll do the same exact thing that we did before, $0 not equal to an empty set. Okay, once we remove any empty elements, we want to check to make sure that things are actually numbers, because it's possible somebody could type in something that's not a number. So we'll go if let, the lower bound should come first, be equal to double. What am I doing here? Configuration string. The first element. Then we'll append the lower bound. Lower. And if we can't do that, we'll need to throw an error. So in here then we'll have to print not a valid number. And we may as well say what is not valid, so we'll call that configuration string. Configuration string. Configuration string. Oh, yeah, 0. There we go. All right. So if it's not a valid number, we may as well print out what's not a valid number. Okay. We also need to do this to the upper bound. If let upper equal configuration string dot filter no, not filter. This one will be 1. Yeah, if upper equals configuration string. 1. Oh, double. Configuration string. 1. Okay, then we'll say upper bound. Dot append upper. Else print not a valid number, and this one will be configuration string dot 1. All right. Okay. So that's good. We've got that. Now we're still missing a return. That's still a problem. And so what do we want to return in this case? Well, we want to return the lower bound and the upper bound. So this should successfully parse a basic input of 2 columns separated by a comma and a space, separating the numbers in the columns, and with each line separated by a return. Okay, so that's useful. So we've got that in here. We have our view controller now, and in our view controller we've got this wired up, but we don't actually make use of the limits of integration text anywhere. So that's the next thing we have to do. So we should be able to parse text, return the upper and lower bound, and that's good. And so we now come back to our view controller, and we're going to have to start making use of this. All right, so just like we did before, where we added items to our select item with titles, we're going to want to populate the integration limits text view, or limits of integration text. Limits of integration text dot string, and we'll set that equal to 0.0 comma space 1.0 with a return, and then we're going to want to repeat this 10 times because one of our functions is a 10D integration, and so we don't want to type that in every time. Oh. And so 1, 2, 3, 4, 5. Why is it doing that? Don't know. 1, 2, 3, 4, 5. Good. And then I can copy this one more time. Paste that in, and that should be 10, I hope. Now if we build the code, we now see our limits of our integration are populated. It has limits 0 to 1, and then we could change or edit all of these. Now it doesn't make use of these limits right now. It just puts in values. Since I'm kind of tired of typing in the number of guesses and number of integrations, I can do the same thing here. So I can do number of guesses dot int value equals 3200, and I can do number of iterations equals 16 dot int value. And then I won't have to keep typing that in all the time either. So build that, I can hit integrate, I get my integral value. Now I don't have to type in everything every time. Good, probably should have done that earlier. But that works. All right, so we have this. So now where do we need to get these values for the limits of integration? Well, probably it's best to get them when we actually start the integration. So if we put it in the start the integration function, we can start this by getting the limits of integration. So we'll say get limits of integration. And so we'll let integration limit string equal there we go, limits of integration text dot string. And so then we'll say limits of we got to create a variable here, yes. Var limits of integration into integration, and we'll just give this a value double. Well, may as well make it a good limit to start, just 0. So we're giving it an array of one value of 0 and 1, and so it's a tuple. Perfect. So we have that. So now we can say limits of integration is equal to the return from parse string, where we pass in the integration limit string, and the separator that we're passing to is going to be comma space. All right, so that will return our limits of integration. Now, if we could trust people to type in exactly what they want every single time perfectly, this would be enough, but it's unwise to do that. So we're going to test to make sure the number of dimensions matches the number of integration limits. Now, in this case, we'll make it so matches equals or exceeds, so we don't have to delete 20 values if we do a 20-dimensional integral to get to a 1. It doesn't make sense. So we can leave more. It just has to have the one limit that we want. Okay, so we'll create a variable, safe to calculate. And we'll say that's false. And so we'll say let number of lower limits equal to limits of integration, the first value within the tuple, dot count. And we'll let number of upper limits equal limits of integration. This will be the first one. and get the count. Okay, now we have to be a little bit careful about how we do this now. So if the number of lower limits is greater than or equal to dimensions, then we'll set safe to calculate equal to true. Then we'll check if number of upper limits is greater than or equal to dimensions. Why does it not like that? Dimensions isn't fine. So somewhere we had decided dimensions would be a double. Probably shouldn't have been that, so we'll make it int dimensions. Do the same thing there, int dimensions. And then we need an and here because we have to make sure that and is also safe to calculate. Because if this is false, then we don't want to accidentally set it to true if it failed the first condition. All right. Oh, we have two ifs. That's part of the problem. Okay. Don't do that. So that's that one. There we go. So if this is true, then safe to calculate is true, else safe to calculate is false. Then if it's not safe to calculate, print there was an error in the limits of integration. And then we don't want to do the calculation because we'll probably blow up, so we'll just return here. So if that works, then we can go on and there's no harm in actually doing the calculation. So once we've gotten through that, everything is good. Now, right now, our code doesn't make use of the limits of integration. So we actually need to change that and actually pass that into the function. So we'll say lower limit is going to get limits of integration dot 0. Upper limit, we'll get limits of integration dot 1. If I wanted to, I could have made a variable instead of passing these parameters in like this, but it's all fine. Now I'm going to get an error message because it has no idea what these functions are because these parameters aren't in my integration function. So I also need to add them in here. So I need to have lower limit is an array of doubles, and upper limit is also an array of doubles. Now I still don't use those values because I haven't put them in for anything. Let's see, what do we have? Oh, yes. Got it fixed by adding self. I also need to add self here because self belongs to the class and not to the local function. Could have made a variable up in here and used that, but I didn't. But that's fine. Okay. So we have to include the class. All right, so now the limits of integration get passed to our integration function, but they're not passed to the calculate the Monte Carlo integral. It doesn't make use of those yet. So we have to add that into here as well. So we have to pass now, along with the guesses and the function to be integrated, and we also have to pass the lower limits. And so that's going to get lower limit, and the upper limit is going to be past upper limit. And we should get an error message here because these don't exist in our function call to the Monte Carlo integration. And so we need here lower limits in our calculate Monte Carlo integral. That needs to be an array of doubles, and upper limit also has to be an array of doubles. Okay. So the upper and lower limit are just going to replace, basically, the 0 and 1 in our dimensions. And that's why we didn't get rid of this value of j, because we actually need it. And so we're going to take lower limit of j, and this one will be upper limits of j. Now we've got rid of our limitation on 0 to 1. Now, that's, yeah, real-time programming, don't do it. Now here we have an immutable value I that was never used. We actually don't need this value. We aren't using the iteration of the guesses for anything, so we can get rid of that. So we don't need a value of I, so we can put an underscore there that just says throughout that value because it's not important to us. So now we can do the integration over various limits of whatever choosing that we want, and this is actually a good thing. So we've greatly expanded the usefulness of our program. However, if we go ahead and run this calculation right now, it will not work. And that's because we still have a major problem. Yeah, that should be done. But all right, but let me build it. And so if I integrate e to the minus x, amazingly enough, it still works. That's good. The problem is what happens if I change the limits of integration and now integrate. So this, the limits of integration of e to the minus xx, should approach 1 as I raise the limit of integration. But if I hit integrate now, the number has actually dropped. And there's a good reason for that. And that's because of this term here, let volume equals 1. We made the assumption when we were doing this that our box was always going to have a unit volume because it was going to go from 0 to 1 in every dimension. So 0 to 1, 1 minus 0 times 1 minus 0 times 1 minus 0 was always going to be 1. And so now this is incorrect because the volume of our box over which we're doing the Monte Carlo integration is no longer 1. When we changed the dimensions, this should have become 2. So we need something that actually calculates the volume of our multi-dimensional box now. So we have to add a new function to actually do this calculation. And in this case, I think about things like boxes and things as objects. So in this case, I'm not going to make just a function. I'm going to create an object in a class. So let's add a new file. But instead of just doing a Swift file, we're going to make a class. And this one I'm going to call bounding box. No, bounding box doesn't exist anymore. So that's going to be NS object. All right, and yeah, that's where we're going to put it. So now we have a class bounding box, and it will have some of its own parameters. And so the bounding box is going to need a variable for number of dimensions. And we may as well start with that being 1. It's going to need the lower range. As an array of doubles, and we'll populate that with an empty set. Because I'm populating this with an empty set, I should probably make the number of dimensions equal to 0 so they match. We'll have an upper range, which is also an array of doubles. Initialize that with an empty set, and we'll have a volume, and we'll initialize that with 1. Now we need a function init with dimensions and ranges. And I'll take input as dimensions, and that'll be an integer. We'll have a lower bound. That'll be an array of doubles. We'll have an upper bound. That's also an array of doubles. And this function, to be safe, we'll take our upper range, remove everything, our lower range, and remove all the values that currently exist. Then we'll set the number of dimensions equal to the passed-in value of dimensions. And we'll set lower range to be equal to the value passed in as lower bound. Yeah. Since it has no values, we'll add that in, and we'll do the same for upper range. And that'll get the upper bound values. All right. So those make those two variables that belong to the class, the array of doubles, equal to, oh, there's no doubles. There we go. It's got to be a double. All right. Upper range, upper bound. And then we want to have a function that basically calculates the volume based on these sets of parameters. So lower will be the lower range, upper will be the upper range, and dimensions will be number of dimensions. All right. Now it doesn't know what that function does, so we have to come here and create that function, calculate volume. And this will be lower, which will be an array of doubles. There's no. Upper, which is also an array of double. And dimensions, which will be an int. Now this function is going to have to be now loop through the number of dimensions, which would also help if I spelled that right. Dimensions int. Number of dimensions is an int. Okay. Let me see if building this causes that to go away. It does not. Build failed. Still doesn't like that. Double. Calculate volume. Lower range. Upper range. Dimensions. Oh, it's got to return a double. There we go. All right, there we go. That is taking care of that. Yeah, sometimes the error messages they give you are not necessarily the most useful, but it is what it is. All right, so somewhere down here, we know we're going to have to return the volume. So we're going to need var the volume. And the volume should start with 1 because it makes it easier to do multiplications if you have the volume equal to 1. We're also going to have to check that the number of dimensions matches the number of parameters that we pass through it. So we also have to do here the same safe to calculate that we just did earlier. Safe to calculate equals false. All All right, so if lower.count is greater than or equal to dimensions, safe to calculate equals true. If lower.count or upper.count is greater than or equal to number of dimensions. What did we call this? Dimensions. Dimensions and safe to calculate is true. And I always like putting parentheses around that. Then safe to calculate is true. And if not, we want to make safe to calculate equal to false and print out the limits did not match the number of dimensions. Okay. Then if it is safe to calculate then we want to do for I in 0 less than dimensions. And the volume is equal to the multiply is to be multiplied by upper of I minus lower of I. Okay. Now else, so if it's not safe to calculate, we still have to return a value. And so we should say else the volume equals 1.0, and we should print the volume value is incorrect. So we know that the calculation is kind of useless, but we still have to return a value for this in any case. So we'll return the volume. Yep. There we go. All right. Return the volume. So this function should work. So now we have to get the volume here in the view controller. So here now we have to calculate the volume of the multi-dimensional box, All right, now to do that, I'll have to instantiate a bounding box. So we'll let my volume equal bounding box. All right, now we can use this to calculate. And so we'll initialize or instantiate my volume. Init with dimensions and ranges. And then we have to give the values. So dimensions will be dimensions. And Dimensions, guesses. Yes, this has to be int.dimensions. Oh. Lower bound will be lower limit. Upper bound will be upper limit. And then we'll let the volume be my volume, not volume. All right, now this should actually work. Oh, and we've got an error. What is our error? Oh, yeah. Okay, we got to add self because it's inside of the. Yeah, I don't know. That's a feature to the language. So now we build, and it should work. All right. So now if I calculate this, I get the right integral from 0 to 1. I make this 2. Integrate that, and it goes up to 0.86. I go to 3, integrate 0.94, and as we keep going higher and higher, we get closer to 1 as it should. And then it will eventually exceed it. It should go above and back and forth because these are random numbers, but that is exactly as we expect. So that's good. So this behaves exactly as we want it to. Now, one of the problems you get when you do these limits of integration and exceed it like this is that you do end up with problems with the number of guesses, right? I can get a pretty good value with 3,200 guesses going from 0 to 1. But if I spread that out over 0 to 10 or 0 to 20, my accuracy actually goes down. So I would really want to up the number of guesses over the longer amount of space that I actually deal with. All right, so there's one thing I still haven't done yet. I haven't triggered the progress integrator, or the progress indicator to go. And we put that in, and so we really should actually start the progress indicator and stop the progress indicator. So when would we want to start the progress indicator? When we start the integration somewhere. So start the integration somewhere in here. If safe to calculate, so we can go progress indicator dot what is it, start animation, and we'll send it myself. And then when we finish the calculation down here, I want to go self dot progress indicator dot stop animation, and again I send it myself. Stop. Now I can build this. And so let's go to the 10D integral, which requires more. And let's add a guess. And now we should be able to see this. When I hit integrate, oh, that was very fast. Okay, let's make more guesses. That's part of my problem. Integrate. So now I can see the progress indicator going until it actually finished. This may have been a little too long. but my progress indicator now will spin, so I at least know that some calculation is actually taking place. That's a good thing because I actually want to be able to do that. Yeah, okay, that was definitely too long. So let me stop that. And then I'm going to do something else here. Don't like how that's showing up in the... So instead of setting the string, I'm going to go string value. Make that 3200 because I don't like it putting the comma in there. That gets confusing to me. So now we can build it again. We can do 10D integral, hit integrate. That one actually was pretty quick. Don't really want that. And so let's go and just add one more. There we go. That should show us long enough with the bar. Starting, operating, and it works. All right, so that is behaving exactly as I want it to now. So that's good. We can change all the limits of integration. So let me go ahead and kill that. All right, so now the program is much more useful than it was originally, but we're still missing something. We've added a bunch of things, but we haven't added any testing for them. And so we should actually make sure that some of these things that we're doing actually work and have unit tests associated with them. So we need to go ahead and add some unit tests. So one of the things we actually want to do in here is add a unit test. Test string parsing. And so we'll let integration limits text, integration limits text be equal to 0.0, 1.0 with the return 2.0, 3.0, and there's a space in there. 4.0, comma space, 5.0, and 6.0, comma space, 7.0, \n. And so then we'll say let return limits equal parse string, and we'll pass it the integration limits text, and we'll pass it a separator as we did before that is equal to comma space. And then we'll check with our assert equal. And we'll assert that return limits dot 0, and we'll just check the third parameter, is equal to 6.0 with accuracy of 1e minus 7 because this is still a double, and we'll print does not match. If it doesn't match, we'll do another assert. And we'll check return limits. We could check all of them if we wanted to, don't really need to. And 1, and that should be equal to 3.0. Accuracy 1e minus 7. And we'll say print does not match. If that doesn't match. What do we have? And so I must have spelled integration limits text. Okay, copy, paste. There we go. And they really enforce you to have white space consistent on both sides, so we'll fix that. All right, so that gives us our test parsing string. And then we also want to test our volume. So we'll do a function test volume. And so we'll instantiate our bounding box class, my volume box equals bounding box. And we'll say let dimensions equal 5. Let lower bound equal, and we'll just give it some numbers, 0.0, minus 2.0, 3.0, 4.0, 1.0. And for upper bound, to make this test easy, we'll just make a function that's lower bound mapped to each value in upper bound plus 2. And we'll do this so it's easy to calculate. The expected volume. And so the expected volume should just be the difference in all these, which in every case will be 2 raised to the power of dimensions. So we'll say my volume box dot init with dimensions and ranges, and we'll pass along dimensions. Lower bound and upper bound. And then we'll see XCT assert equal. And this will be my volume box. My volume box dot volume is equal to power 2.0 raised to the, now it's got to be double dimensions. And then we need accuracy. That's spelled wrong. Accuracy, there we go. 1e minus 7. And if not, print does not match. Okay, so now we can actually run our unit tests. Build failed. Now what? Missing parameter. Oh, yeah, we didn't fix these in our unit test. Ah, our other unit tests now are now wrong. Ah, yeah, we have to fix that. Okay, so we got to fix all these here. Oh, joy of joy. Yeah, broke all our other unit tests by fixing the program. Yeah, got to change these things everywhere. All right, so this one in this case, e to the minus x is easy, so we'll just pass the limits of 0, 0.0, and 1.0. And we have to do the same thing in the e to the x. Nothing else actually changes there, so that's easy to fix. Where this becomes a problem is in the 10D integral. And so it's a little bit more challenging to do here. So we'll add that one, wait for it to figure out its next error. Now, in this case, the limits of integration are a little bit more challenging, and so it's easier just to create so let lower limit equal the array 0.0, comma, and we'll put in 10 of these. 1, 2, 3, 4, 5. Copy. Command V, and that should give me 10 of those. And now we'll make these all ones. And that will give us our 0 to 1 on the limits. So we can test this. All right. So then we need to pass in here lower limits, pass in here upper limits. There we go. Now we can run all of our tests, and all of our tests should pass. We hope. Test succeeded, we're good, all of our tests passed. So now we have a very useful program. It works how we want, but there is still another major flaw that we actually have. And we do actually want to deal with this. We've written good code, we've written a program that does what we want it to do, but the one thing it is failing at still right now is we haven't well documented it. And so we actually do want to do this. So we want to go into all of our functions and add, using the editor structure, add documentation. So our function here, parse string, takes parameters, a string with parameters that should contain lower and upper limits for each dimension the descriptor, this is the separator, separating the values. That should be parameter values. Could be, comma, space, space, tab, etc. All right, so that's good. That tells us now a lot more about this value. Can come down in here, do the same with bounding box, with dimensions, editor, structure, add documentation. And this is init with dimensions and ranges. And this takes the number of dimensions of the box, is an array of lower dimensions of the lower limits and space of the box. And this is an array of upper limits in space of the box, and should be equal than the count. Should be equal to or greater than the dimensions. And again, the count should be equal to or greater than the dimensions. Come down here, do the same thing for calculate volume. Structure, add documentation. And we can pretty much copy the same parameters for that. And then I like to give one more. It returns the volume of the multi-dimensional box. So now when we look at this 5 years from now, when we're using it in another program, we'll be able to actually figure out what it's actually doing. We'll do the same thing in here as well. In our Monte Carlo calculation. And they do make it very easy to add this documentation in Xcode, which is very useful. Number of dimensions, guesses, this is the number of guesses in each iteration. Lower limit will be the lower bound of the integration, and needs one per dimension. Needs one value per each dimension. The upper limit is the upper bound of the integration, and it also needs one value per each dimension. Function to be integrated is the passed in function to be integrated over the range lower limit to upper limit, and must be of type integration function handler. All right. E to the minus x. It's pretty straightforward. Probably didn't need to do this, but we'll do it anyway. Add documentation. E to the minus x. Number of dimensions. To match type integration function handler. An array of inputs. The inputs for each dimension to be calculated. In this case, only first is used. All right, there we go. And this must be an array to match type integration function handler. E to the x, do the same thing. Editor, add documentation. E to the x. Now I'm just going to copy this because this is the same. And so we'll also add down in here. Returns the value of exp of x. That's minus x. Here we'll have returns the value of e to the x. Perfect. 10D integrals a little bit more complicated. And so with 10D integral, product, editor, structure, add documentation. Still much of this. All right, and then this function is more complicated. And so this is actually going to return the value of x0 plus x1 1, 2, 3, 4, 5. All right. that's right, x1, 2, 3, 4, 5, 6, 7, 8, 9, and that's going to be the quantity squared. All right, that's useful. So now we have a good description of what this function actually returns. And we can go to our view controller as well and see what should actually be commented out there. A function selector is pretty straightforward. Start the integration, editor, structure, add documentation. Sender doesn't really matter. Normally, it will be the integration button in the GUI, and this starts the multi-dimensional integration. Okay. Product, or editor, structure, add documentation, integration does the heavy lifting, and performs the threaded Monte Carlo integration. Iterations, number of iterations, number of guesses, an array of the lower limits of integration, and should be greater than or equal to the number of dimensions. The upper limit is the array of the upper limits of integration and should be greater than or equal to the number of dimensions. The queue is actually the queue in which we will perform the threaded integration, and this can be concurrent or synchronous as needed. Testing usually done synchronously, calculations done concurrent. All right, so that gives us a good description of that. And that takes us through our entire code so we can build and run. And we get a very useful program that can calculate multi-dimensional Monte Carlo integrals. We can extend it easily to any function that we want. with any number of dimensions and any limits of integration that we want to use. So this is a good, useful calculation. We've used good variable names, and we have used good commenting practices throughout the whole program. This is going to be very useful and can be easily reutilized going forward. This is the kind of code that you really want to write. This is how you want to do things. These are good practices. So I hope you learned a lot from this, and thank you for watching.